Dumb weather comp versus intelligent weather comp. These are terms that we've coined in the forum to let us know what we're talking about, because there are different versions of weather comp, and generally the two that we're referring to are on the Viessmann 200 versus the Viessmann 100, and these are sort of approximate graphs to explain the difference between the two. So if we start with dumb weather comp will give you a series of curves that you can select, but these curves are pretty much fixed, and they're also don't appear to me to be linked to any curve that I would ever want to use. But they will adjust flow temperatures based on outside temperature, so they will give you raised efficiencies, but these need to be used, in my opinion, with an internal room stat or internal control to give you accurate temperature control. You're not going to get it otherwise. And also, these you can't select multiple curves, and you can't adjust the shift. So you can't adjust for temperature. You need a separate control to adjust for the temperature. So that's dumb weather comp. Pretty much it gives you some efficiencies based on the outside temperature, but really doesn't do much more than that. This, I believe, is the cause of a lot of people saying that weather comp doesn't work, because this weather comp kind of doesn't work. It's got to be done with a room stat. So if we move over to the principles of the 200 are the similar principles that they use on the Valent boiler, and I think on a few of the other manufacturers now, Navion, ATAG, and Worcester, I think, follow a similar theory now, where you've got these adjustments, and some of them you can really reshape these curves. I think on the Worcester you can set multiple different positions across the curves. Not quite sure why you'd want to, but maybe some Worcester experts could explain why. That would be quite useful, and maybe Worcester have got a USP to put forward for us on the forum here, where they've got even a higher level of control possibly on their weather comp. Anyway, saying that, the Viessmann one seems to work perfectly well, and it has all these levels of control. So basically all the curves on the Viessmann weather comp amalgamate back at a start point, and this start point is usually a match between the flow temperature and the design room temperature. So this would be a flow temperature of 20 and a room temperature of 20, and kind of worked out that the DT at this point would be 0, and the reason it'd be 0 is pretty much it's turned off because there's no heat requirement. And what I believe happens is that at your main design function you'll have your delta T20, but that delta T is going to drop back and narrow as we come back down this curve. We'd like to keep it wider, but when you're using a low temperature system, you've already pretty much milked the system for all the efficiencies when it's at high load. So there's not much gain beyond that point. Don't get confused with what I'm saying. That doesn't mean that it's not efficient. It means you've already got all of the efficiencies when you're at maximum demand, or most of the efficiencies you can gain when you're at maximum demand with that design. Doesn't matter how the design of the system is, weather compensation will always give you more efficiency, because it's always going to drop back down these curves and get the boiler running cooler than it would if it didn't have weather comp, or some kind of load compensation system anyway, at least. Got to bear in mind that weather comp isn't the only load compensating system. So intelligent weather comp, basically you can adjust the level or shift, which is in fact they run up and down this line here. This is your representing your shift, and you can adjust your curve here. So this one can be adjusted this way, and then the whole curve can be adjusted this way. So a little example for you here. That curve we've got there, if I go and turn the room temperature, it simply moves it up like that. So it's exactly the same curve, but it's running at a raised temperature throughout the whole length of that curve. This could be on as many circuits as you want. You could have multiple mixers here. They could all have their own temperature and time programs so you could have them running at different curves and slopes and time programs and everything. Underfloor heating, by the way, runs at very, very low temperature here. A high temperature for underfloor heating in a well-designed underfloor heating system could be as high as 35 degrees. Once you go over this, really you're running into radiator territory. But there are occasions with a poorly installed or poorly designed underfloor where you might need higher flow temperatures. Or if you've got extreme outside temperatures, you might need to go out of this as well if you haven't got good insulation in the property. So, okay, hope that helps.